common question I get is, how do you simplify something like this, the square root of 420? I mean, my students often know that the square root of 36, for example, is 6, but if it's not a perfect square or a perfect cube, how do you reduce these things? So I'm going to show you how to do this, and you can do this using something called factorization. So I'm going to take 420 and I want to break it down as much as I can into just a product of primes. So when I'm thinking, okay, maybe that's 10 times 42, and I can break 10 down into 2 times 5, and I can break 42 down into 6 times 7. So now what this means is 420 could also be written as 2 times 5 times 6 times 7. And then I could break down, well, the 2 and the 5 can't break down anymore, but the 6 can, as the 2 times 3, and then I have 7. And now notice that these are all prime. Okay, this has a name, and it's called prime factorization. And believe it or not, prime factorization helps you figure out the square root of 420. Because when I'm taking the square root of 420, remember, I'm thinking of what times itself 2 times gives me 420. So when I look at the prime factorization, anything that shows up twice in my list can be taken outside of the radical. So for example here, since 2 shows up twice, if I want to take the square root of 420, see, that means I know that that's the same as the square root of 2 times 2 times 3 times 5 times 7 from the prime factorization. The 2 shows up twice, so I can take that outside. I have 2 times the square root of 3 times 5 times 7. So the square root of 420 simplifies to 2 times the square root of 3 times 5 times 7, which I believe is 105. So that is a good way to evaluate what the square root of 420 actually is. Let me show you one more just to practice. Okay, so this time we're going to look at the cube root of 128. So the same principle applies, the same strategy applies, but since I'm taking the cube root instead of the square root, I need things to show up 3 times in unique factorization, the prime factorization. Alright, now 128 actually I know is the same thing as 2 to the 7th power. So I can just write this as 2 times 2 times 2 7 times. So that means now when I'm looking for the cube root of 128, I need things to show up 3 times. So notice here's 2 shows up 3 times, and then 2 shows up 3 times again. So what that tells me then is that the cube root of 128 can be the cube root of 2 times itself 7 times. That comes out twice. I have 2 times 2 times the cube root of 2. So the cube root of 128 is the same as 4 times the cube root of 2. And that's how a good way to write it. So if I wanted to do the 4th root, for example, I just need something to show up in the prime factorization 4 times, and so on. I hope this makes sense. This is a very valuable tool to have. I'll be glad to help if you have any questions, and thanks for watching.